Precise geometric modelers, or rather BREP modelers, are at the essence of the innovations achieved in the 3D modeling world over the past several decades. Much of the world we live in today has been designed with these precise representations and support many critical industries' workflows, from AEC all the way through to shipbuilding and beyond. Human bodies, geological entities, the Earth itself are not well suited to be precisely modeled. Similarly, point clouds and voxels are also not well represented using a precise modeler. If you need to design or model these entities or other non-precise representations, polyhedral modeling is fast becoming the preferred solution and is often the only practical way to model some objects. When you think of polygonal or faceted representations, we are talking approximating surfaces using polygons. Often, the polygons are simply triangles, but they can also be quadrilaterals. Basically, any simple polygon can be used as an approximation, a representation in the world of 3D models. Polyhedral modeling is often fast because it is an approximation. It allows the user to generalize and decimate, making it good for approximating complex items and shapes, which would otherwise pose a challenge for a precise modeler. But polyhedral modeling itself is not perfect, since we are talking about approximations. A sphere, for example, requires a lot of triangles to model accurately, making the polyhedral model very complex. Even a complex polyhedral model, or the sphere, is still an approximation, whereas a precise or BREP model can represent the sphere very cleanly in a mathematically precise way. But what happens when you need to model using both precise and polygonal representations? Enter hybrid modeling. Hybrid modeling is taking the best of both the polyhedral and BREP modeling worlds. Using a 3D printed titanium rib cage as an example, the bones, because those are organic, can be well represented with polygonal shapes and models, but the titanium rib cage itself needs to be manufactured and starts as a BREP model. Bringing the two together is a challenge that hybrid modeling can solve with its ability to combine those two together to achieve new results and innovations. Here we are looking at a connecting rod and booleans that are taking place. This is a combination of BREP and polyhedral modeling. The offset was done with the precise model. We are now looking at wireframes. And then we're going to take a precise planar slice. This is where we have combined BREP and polyhedral to be able to take advantage of the strengths of each of those representations and model the connecting rod as a single body. The best representation will maintain that native form whenever possible. In this example, we see an engine block that we interact with a polyhedral entity with the BREP engine block. The resulting body, after we've done a subtractive Boolean operation, means all faces and surfaces that interacted have now been converted into polyhedral representations themselves. However, the other parts of the engine are still precise. We can perform additional operations on this. For example, we can create offsets on the cylinders. The blue and red are now showing BREP offsets made possible because of precise modeling. The cylinder, because it's round, is well represented with BREP. The final body has taken advantage of the polyhedral and BREP modeling wherever possible, so that the storage, processing, and ultimately the workflow has benefited from the best of those representations. To learn how you can take advantage of Spatial's hybrid modeling solution, CGM Polyhedra, visit www.spatial.com.